Ladies and gentlemen, boys and girls, children of all ages, today's video that you are watching intently is going to cover two different things that are going to help you. One of the items on the Mountain Math asks you to do some prime factorization and make a factor tree. Well, as I said earlier, some of this stuff is preview for future stuff. It is. And I'll always go around and help as you're working on it. But in addition, I'm going to do a little demonstration here of finding prime factorization, which might also be listed as a factor tree. Or factor tree. All right. This kind of stuff. Oh, really? Thank you. I thought you were going to ignore me. This is going to be vitally important as we move towards fractions and simplifying fractions and finding equivalent fractions, which we will be starting, what's the word for it? Very soon. Very soon. We'll be starting very soon. So they're going to give you a number like the number 24. And Jacob is with me. He is paying close attention. Really, when I say that, I'm being sarcastic because he wasn't paying attention, and I'm trying to draw his attention to me. Because when I said, and Jacob is with me, he's like, and then started paying attention. See, it works. So teachers, it works. And I didn't have to call him out and tell him to be quiet. I just said, Jacob's with me, so I didn't embarrass him at all. He just turned and was with me. I'm just saying. All right, so you may have a problem that gives you a number, and it says, find the prime factorization of that number. Well, in order to do that, sometimes you'll use what's called a factor tree. Now, the word factor, as we've learned, are the numbers that you're multiplying together. So this first two branches of my factor tree are going to be two numbers I can multiply to get 24. There are many. But you can't use one. Nowhere in my factor tree do you have the number 1. So I can't do the number 1. Okay? It doesn't matter what you start with, as long as the factors have a product of 24. So Andrew, what is one way you can multiply together to get 24? 6 times 4. I could put 12 times 2. I could put
8 times 3.
8 times 3. I could put any of those here, and I'm still going to have the same prime factors when I'm done. Now I have to figure out if either one of these is a prime number. Well, a prime number has 2 factors. And only 2 factors. 1 and itself. Well, I know 1 times 24, so there's my 2 factors, but it also has 6 times 4, so that's 2 more factors. It also has 12 times 2, that's 2 more factors. It also has 8 times 3, so the number 24 has 8 factors, which means it's a composite number, which is more than 2 factors. A composite number, which is more than 2 factors. So now we got to think here. We have the number 6 and the number 4. Macy, Is 6 a prime or composite number?
I would say composite.
A composite. Because there are more factors than just 6 and 1, right?
Yeah.
So besides using 1, how else, what are my other factors that would multiply together equal 6?
2 times 3.
2 times 3. Macy, 4, composite or prime? Composite. And what are my factors besides 1 and 4 that I can multiply together to equal 4? 2 times 2. So 4 has 3 factors. 1, 2, and 4. 3 factors for the number 4. Okay, and I'll give you a hint right now. I'm not telling my other classes or anybody else. So if you're watching this, plug your ears. The only even number that's prime is 2. The only even number that's prime is 2. Why? Because 2 is a factor of every other even number. If you give me an even number, 2 times something will equal that number. But not every odd number, because 21 is composite, because 3 times 7 equals 21. 15 composite, because 5 times 3 equals 15. All right, so let's look here. Bailey, 2, prime or composite?
Prime.
Prime, because she knows I just said 2 is the only even prime number. Brady, 3, prime or composite? Prime, because the only factors of 3 are 1 and 3. Once I'm done, I don't have any more branches to make. I have only prime numbers here. Then I can write my prime numbers 2 times 2 times 2 times 3. And if you know how to multiply, that will equal 24. But let's just see. Who's the smartest kid in here? Okay. All right. I believe. Matilda, what is 2 times 2 times 2? No. 8. I guarantee you I'm going to get people all year long. When I say 2 times 2 times 2, I'm going to get people to say 6. But it's 2 times 2 is 4. 4 times 2 is 8. Yeah, y'all were raising your hand saying 6. That's what. And then 8 times 3 is 24. Let's look at another one. Let's take the number 15. The number 15. Dylan, prime or composite? Composite, good. Any number that ends in 5 besides 5 is going to be a composite number. 25 is a composite number because 5 times 5 is 25. 1,285 prime number or composite number because 5 times something is going to equal that. Okay? So Dylan, besides 1 and 15, how else can I multiply to get 15? 5 times 3. Now, we already said in the last problem, 3 is prime. Carlos, what about 5? Prime or composite?
Prime.
Prime. Because the only factors of 5 are 1 and 5. That means I'm done. My prime factorization of 15 is 5 times 3. But what if it's a prime number? I know 3 is a prime number. I'm done. I can't make a factor tree of 3. Because I can't have 1s in my factor tree. And the only factors of 3 are 1 and 3. Go ahead. So that is one thing we're going to talk about. The other, I want to do a quick division problem because, as I said yesterday, I'm seeing some decimal points in the wrong place. So I need to make sure you really concentrate. When you're doing Station 4, divide decimals by whole numbers, I don't want to see decimal points in the wrong place because you're going to get the wrong answer. So let's take the problem 16 and 2/10 divided by 5. 16 and 2/10 divided by 5. Now, my number on the first number here is my dividend, which is the number on the inside. If you want to say it like you're still in elementary school. They're not, but I might send some back. The second number, my 5, is my divisor. Now when I'm multiplying, but with decimals in my dividend, I move my decimal point straight up. We covered this a million times. Then I'm done with it. I don't have to mess with it anymore. I don't ever. And the rock means ever bring down this decimal point. It only moves north. It only moves north. Okay. Let's. Essien. Does 5 go into 1? I am not going to have a number in the tens place. Which means, does 5 go into 16, Essien? Yes. Which means I'm going to only have one number in front of the decimal point. If you don't put them above where they go, you're going to mess up. It's going to make me cry. And when I cry, I tend to have snot running down my face.
That's just like yummy.
So, Essien, you said 5 goes into 16. How many times? 3. And 3 times 5 is what, Essien? 15. And the difference between 15 and 16 is what, Essien? 1. Now, after I subtract, as long as I have another number, I bring it down. And so I bring down my 2. Isabella, does 5 go into 12? Yes. So I have to have a number above the 2. How many times is it going to go into 12? 2. And 2 times 5 is? 10. And the difference between 12 and 10 is what, Isabella? 2. Now here's where we have the problem. Here's where the hands are raised. Here's where they're crying. Jacob J.
It is your.
See, I'd call him again so I can get his attention. Jacob J. I can't have a remainder.
What?
And right now I have a 2 when I subtracted. Do you have any idea what I can do to try and eliminate this remainder, Jacob J? Boy, 75% of the rest of them know. I can add a 0 in the dividend.
Are you kidding me?
Behind the last number. I can add 57 zeros. What do you mean? I don't get that. This is $15, correct? And the decimal point is right here. It's always behind the ones place. This is also $15. I can add these zeros at the back behind the decimal point without changing the value. So 16.2 is the same as 16.20. I change this to 16.20. So now I have to have a number above the 0. And I have to bring it down. Jacob J. How many times does 5 go into 20? 4 times. And Jacob J, 4 times 5 is? 20. Now I subtract and I have nothing. If I had something else, I could add another 0 there. Or another 0 there. Or another 0 there.
So
Yes.
you constantly add zeros until you have no remainder.
Well, most problems, if you're going to do that, it's going to say round to the nearest hundredth or something like that. And then you would go out to the thousandths place and then round it back to the hundredths place. Now there's a problem that you're going to see, and it's going to be 12 divided by 15. You're going to see that problem, and then 63% of you are going to raise your hand and say, well, you can't do that. Well, you can if we make this 12.0 divided by 15. Boy, light bulbs going off right now. Light bulbs going off right now. Brooklyn, you have a question.
I got a different answer than you.
That's not a question.
I got 3.23.
3.23?
3.24.
All right, let's see. Okay, work with me here. Did you get a 3 here at the top? Did you get 15 here?
Yes.
Did you get 1 when you subtracted?
Yeah.
Did you bring down 2?
Of course.
Okay, so did you get 10 to subtract from 12?
Yes.
And did you get 2 when you subtracted that?
Mm-hmm.
And then you brought down a 0.
There was no zero. Okay.
But you can add the 0. We said these were the same, right? So if you add the 0 there, because I could add 64 of them if I wanted to. All right, she wants to see another problem. Well, let's do this one. Which, I'm just saying, might come in handy sometime in your near future. So Brady, does 15 going to go into 1? Is 15 going to go into 12, Brady? No. I am not going to have any whole numbers. Nothing in front of my decimal point. No whole numbers. So Mariah, any idea how many times 15 goes into 120? No, sir. Give me, normally you'd list your multiples, 15, 30, 45, right? Normally. Okay, so give me an estimation. We know it's more than 3 because 3 is 45. If 3 is 45, 6 would be, what's 45 times 2?
45 times 2.
Good, that would be 90. So 6 is 90. So we know it's more than 6. So what do you want to try? Now let's try 15 times what? I want to get as close to 120 as I can without going over. Good. 7. And we'll see if 15 times 7 works. Okay, Mariah, what's 7 times 5? 7 times 5.
7. Oh, 5.
I know. You're going 7 times 9. That's fine. 7 times 5. 35. Excellent. 5, 3. Mariah, what's 7 times 1? 7 times 1. 7 times 1. 7. Add 3, you get 10. Okay? So is 105, do you think that's as close to 120 as we can get? It is 15 times 8. I don't have to add any more zeros. I have an 8 in the 10th place, which means I could look at my answer choices, find the number in the 10th place, and just cross off any that doesn't have an 8 in the 10th place, and a nothing in the 1's place. Boom! Shakalaka! Peace out! God bless! Love ya! Do something kind today!